always be anti to another hydrogen. As we know, during elimination reaction, always anti-periplanar position is preferable. Hello students, welcome back to another class. Today's topic is alkyl halide, and this particular portion, the reactions are pretty much easy, but they comes with a mixture of substitution nucleophilic reactions and eliminations reactions. So we just have to keep in mind the chemistry of substitution reactions and electrophilic reactions to solve this type of problems easily. Okay, so let's start today's class. Now this question, there is a two reactions, that is reaction 1 and reaction 2, and identify the products. So the first area before the semicolon is the product of the first reaction, and the second part is the product of the second reaction. So in the first option, the reaction 1 is one product and the reaction 2 will 2 products, and so on. Let's find out. The reactions is basically very basics. It's a substitution reaction. What happens out there? This CH3COO group will replace the OTS group, and how? As we can see in the reaction 1, the OTS group is above the plane. So when this group will attack, the OTS or displace the OTS, it will attack from below the plane, and the product will be like this. O, CO, CH3, and the NME2 group will be above the plane. So this product will be the only product from the reaction 1. Now this product is common in all the cases except D. So D will not be the answer. The rest could be the answer, but we have to find out more. Now in the second product, the NME2 group and the OTS group are anti to each other. Hence what will happen? This NME2 group will act as a neighboring group participation, that is, it will attack from the above the plane to displace the OTS group and will form compound like this. Now when this nucleophile will attack, that means when this CH3COO minus will attack, it will attack either in this carbon or in this carbon, and they will attack from below the plane as NME2 is above the plane. So they will form a mixture of enantiomers. So option A, as you can see, the first compound is this one and the second compound is this one and its enantiomer. Okay, so option A will be the answer. You just have to do it by yourself to find out the structures of the enantiomers. One structure will meet this one and another structure will be this group in this side and NME2 on that carbon, nothing else. Okay, so these are the answers and this is our particular correct answer. Okay, so let's go to the next question. Now this one is also very easy. As you can see, there is 3 reactions. One is with this, the second with NBS, and third with KSH. And the final product we have to find out. Now in this compound, when SO2Cl2 is used in presence of HNu or sunlight, the chlorine will replace the most reactive hydrogen. In this compound, this hydrogen is most reactive as this is only the 3-degree hydrogen. Hence, the first product, that is the product A, will be this one. After this, so this will be option A. It's a very clean answer. Now NBS. What does NBS do? NBS is basically nothing but allyl bromination or benzylic brominating reagent. That means N-bromosuccinimide prefers to brominate the compound or the hydrogen in allylic or benzylic position. Now, this carbon is benzylic, so NBS will attack this carbon and replace one hydrogen from this carbon, and the product will, that is product B, will be this CH2 here Cl. And now KSH. What KSH will do? KSH on a reaction with KSH, it will be a substitution nucleophilic reaction. It will replace either chlorine or bromine from this group, and it will follow SN2 pathway. This is a good nucleophile, you can say, but it has been observed that using KSH, it always follows the SN2 pathway. So, among these two groups, benzylic position is more susceptible to SN2 reaction, as this one is more sterically hindered. So, SH group will preferably replaces the bromine, and the final compound thus formed will be this one, SH, and here is the group. So, let's find out. This one is option B, as you can see. So, option B will be our correct answer. This is a basically very easy reaction. We just need to remember these reagents and what type of substitution or reaction they prefer. Nothing much. Now it's time for the third problem. What this problem is means, there is also, now this OTS group will be replaced by OAC group, that is acetate group, and we need to find out the product. Now this start C is the isotopic carbon, and we have to find out after the reaction, this position of the isotopic carbon will be placed where, like it will be placed here, or it will be placed here, or it will be placed here. So it is very clear that OTS group is a leading group. So OTS group, obviously OTS group will be replaced by OAC group. But the question is how? Now this is also a particular case of NGP, that is, in this case, that is CH2, this one is a star, OTS. This carbon, this bond will attack this carbon to remove the OTS group, and hence the product will be like somewhat like this. There will be a positive carbon in the CH2 star. Now OAC minus will attack any of these carbon, either of these two carbon, and that if it attacks this carbon, one of these bond will fall into here, and hence there will be two product like CH2 OAC, where if it attacks this carbon, this bond will break and fall on here, so this product will form. If it attacks this carbon, this bond will break and it will fall on this product. So these two will be our answer, CH2 OAC. Okay, so this is option A and this is option B. So both option A and B will be our correct option. Okay, so let's come to the next problem now. This reaction is an example of Hofmann exhaustive methylation. Now Hofmann exhaustive methylation is a very basic reaction for this reactions actually. What will happen on Hofmann exhaustive methylation? There is H, MEI. The nitrogen will attack Me, the I minus will go away, and it will repeat 2 times. So it kind of look like this. Me, and positive. Now this hydrogen will get removed to form this compound. There will be a double bond, and there will be NMe2. Once again, the Hofmann exhaustive methylation will occur, and this bond will be like this in Me3 plus. Again this hydrogen will be removed and the final compound will be this plus in Me3. So among all the structures, this A is only matches option of the compound, so A will be a correct answer. So in Hofmann exhaustive methylation, one after another methyl group gets added to the nitrogen and the carbon and nitrogen bond get dissociated. This what happened out there. Okay, nothing much. So the last problem for today is this one. This one is a little bit of lengthy, but if you can do it effectively, what will you get? Upon dehydrogenation halogenation of 2-bromobutane, which conformation will lead to formation of cis-butane? Now we can check all of these options, but you can always see that the bromine will always be anti to another hydrogen. As we know, during elimination reaction, always anti-periplanar position is preferable. So bromine and another hydrogen will always be anti. So look, in this case the bromine and the hydrogen is in anti position, so it is a favorable position. In this case bromine and methyl group is in anti position, so this is not a favorable position. In this case bromine and hydrogen is in anti position, so this is a favorable case. In this case also it is not a favorable case. So we have to concentrate on option A and option C. Now you can see in option C both the CH3 group are in anti. So when they will form a product, they will form a trans compound like this: CH3, bromine, hydrogen, CH3, hydrogen and hydrogen. So this hydrogen will get abducted this way and it will form a trans compound like this. But in case of option A, the CH3 group are adjacent to each other and hence this will form a cis compound. You can do it by this yourself. So we have asked find out which conformation will give us the cis-butene. So option A will be our correct answer. Okay, so these are the type of questions that may come from alkyl halide chapter. This is a very basic chapter, but we can focus our study on these topics and we will get a very good marks from this chapter. Okay, so thanks for watching and all the best for examination. Thank you.